Hello, welcome to the world of deep learning. I'm so excited to have you all here. It's really gonna be a fun adventure. So, before I start, I would like to talk a little about the limitations of traditional programming. Well, the limits of a traditional computer program. Why exactly are certain problems so difficult for computers to solve? It turns out that traditional computer programs are designed to be very good at two things: performing arithmetic really fast and explicitly following a list of instructions. And even in a most dumbest way, even in a very dumb way. So, if you want to do something heavy financially, number crunching, etc., you are in luck. Traditional computer programs can do the trick. But let's say we want to do something slightly more interesting, like write a computer program to automatically read someone else's writing, or we're implementing the Super Mario algorithm. Okay, suppose we define our Super Mario's function to defeat all obstacles, or better yet, stride, stride through obstacles. Obstacles could be walls, enemies, bridges, broken bridges, etc. From the beginning to the end of the game, we can find many obstacles. So, deep learning can make it work efficiently. Traditionally, we will define all the methods of the countless obstacles in the game. But if we introduce deep learning, we will have our models learn from the game and sort out the obstacles by itself. After, we must have fed the data into our model. There will be no point writing a bunch of unnecessary or countless functions. We can just encode something like go. Now, the goal is to save the princess from the castle. So, learn the steps to get there, and boom, that's just it. It happens. Now, what actually is deep learning? Deep learning is a possibility to give a computer the ability to learn without being explicitly programmed. We can use a model or technique that learns features and tasks directly from a given data. This can be pretty much anything. These features can be images, text, sounds, etc. Deep learning is often referred to as end-to-end learning, meaning it learns all the features that can occur between the original input X and the final output Y. We could label the input as X and the output as Y. Consider this example for a question and answer task or problem. We can address it as such. X is an original question stating who is the president of the United States, and we can then define our Y, which is going to be our answer, Donald Trump. So the model will learn from the X futures. Futures from this scenario could be a strong vision for the country's future, effective communication skills, yeah, crisis management skills, making America great again skills, blonde hair guy, etc. So the features are endless. With all these features from gotten from our X input, the model will be able to make a great prediction as our Y, which probably suits Donald Trump the most as we would think. But the model will be able to process a whole bunch of features in seconds and make a better prediction. The model is better in making predictions, very accurate. Okay, picture this other example where we run a model that can classify our input data into the right categories. Say we have mangoes, pears, and bananas as our data. We can label this data as mango, pear, banana. We then feed this data into our model, feed the data into our model, the model learns from the different features and the magic happens. There is our expected output in the right class. Amazing, right? The term end-to-end has been meaningfully the term end-to-end has been meaningful in a way that a machine learning model can directly convert an input data into an output prediction by passing the intermediate steps that usually occurs in a traditional pipeline. What has it that deep learning models can now make accurate predictions than humans, and it's really fast. Most deep learning methods use neural network architecture. They use neural network architectures. How is neural network different from deep learning? So we can say normal neural networks usually have one or two hidden layers and are used for supervised prediction or classification, whereas deep learning neural network architectures uses different or many layers rather, so we can say it differs from normal neural network because they have more hidden layers. The main difference is just the layers, the numbers of layers. The term deep learning refers to the number of hidden layers in the neural network. So I often hear deep learning model referred to as deep neural networks. One popular type of deep neural network is known as the convolutional neural network, popularly known as CNN, commonly applied to analyzing visual imagery. Its main purpose is commonly applied to analyzing visual imagery. We will eventually see how it works. So for now, it was so awesome to have explain all these topics to you, all these points. I feel so energetic and I really can't wait for us to indulge more into our course profile. So for now, thank you so much for being in my class. Have a nice and wonderful time after this. Looking forward to see you all again. Bye bye.